In this video, we will take a look at how to use a graph to evaluate a few limits. So once again, take a moment and graph this function here. Plug it into either Desmos or your TI-84. Take a look at the shape, and let's try to figure out what's going on around x equals 1. So one way that's really nice to evaluate limits is to simply use a table of values. You can, of course, generate that on your calculator. You can press the plus button anytime you bring up the table to change the delta table. In other words, change the jump between all the x values it displays. And then you can take a look at the numbers as we did in the previous video and look to see if you can see a trend. Is there a trend? Certainly looks like it's approaching 2 to me, but it's nicer to be a little bit better than kind of sort of looks like it to me. So let's take a look at the picture. And once again, as x is approaching 1, so here's x equals 1, it certainly appears as if the y, the output, is approaching 2. It's tough to tell when you're that far out, so perhaps you'll want to zoom in to get a better look at what's going on. So manually adjust your window, and what you can see is as x approaches 1, so here's your x equals 1 value. As x equals 1, what's happening from each direction? Right? So as x is approaching 1, obviously the function is undefined. The calculator spits out an error. But what's the trend? What's going on? From both sides, it certainly looks as if the output is approaching 2. So that's a nice way of looking at it. Since the output is approaching 2 from both directions, the limit as x approaches 1 is simply 2. So you can do that on a graph if the graph is telling you something. Pretty easy to interpret. Let's look at one more graph, and this is a little bit of a funny one. This graph only exists to teach a concept about limits. That's the only reason that this graph would ever appear, because it teaches a really important point. So this is a really basic piecewise function with 2 pieces. The function value is 2. It's a constant function. The function is always 2 whenever x is not equal to 3. That is, when x is equal to 0, the output is 2. We can see that right here. When f is equal to 1, y is 2. You can see that here. When f is equal to 37.178, y is equal to 2. I just totally made that up. I have no idea why I chose it. That is what it is. So that's, somewhere way off to the right of your screen. The output is always 2 so long as x is not equal to 3. So what happens when x is equal to 3? When x is equal to 3, so f of 3, the function is 0, and that's what this point is right there. It's weird. Again, the only reason that this exists is to prove a point, to teach a point. Because remember, the important thing about limits is the trend. What is the trend over here? As x is approaching 3, what's going on with the y values? The y value is 2 here. The y value is 2 here. The y value is still 2 here. What's happening over here? As x is approaching 3 from the right-hand side, what's going on with the y values? The y values are always 2. What's more important, the exact point or the trend? When it comes to limits, the trend is the most important part. So the limit in this case is 2. The trend overrides this silly little point down here. So the most important part about evaluating limits by a graph is trending.